So the first thing on your notes is 2 vocabulary terms that are specifically used for these word problems. So mathematically speaking, this is no different than what we did yesterday and today as a warm-up. The math is going to work out the same. The difficult part about these problems is we're doing word problems now, and you have to interpret what the problem is asking and draw a triangle. And then when you draw the triangle, you have to figure out if you're solving for an angle or for a side. So the 2 different types of angles that are typically referenced in these problems are angle of elevation and angle of depression. And angle of elevation, I want everyone to write this on their sheet. Typically you go, well always, you go straight out and up. And that's how you measure the angle. Straight out and up. And we're going to write that because that's going to help you if they say angle of elevation in the problem and you get confused. So straight out and up. The other angle is angle of depression, which is straight out and down. So straight out and down. And angle of depression is the one that usually messes with students. So I would say typically when I give a test on this and I have like an angle of elevation problem, usually every single student gets the angle of elevation problem correct, except for maybe like 2 students who were absent that day or something. The angle of depression problem, even for students who have practiced it a lot, it usually is like half the students get it right and half the students get it wrong because it's easy to mess up. So we want to pay special attention to that phrase, angle of depression. Okay? Make sense? All right. So the first example, and for the examples I had pictures drawn for all of those, so when we actually switch over to doing the assignment, I'll help you guys start drawing the pictures. But here it says we have a nursery that plants a new tree, and they attached a wire, which happens oftentimes when you have a new tree. They put wires on it so that the tree doesn't like flop over from the weight of its own branches. That way it can grow straight up. And so you have an 8-foot wire, and they want to know this height right here. They want to know how high that wire is attached to the tree. And they did describe the angle connecting the wire to the tree as being 42 degrees. So just like we did the problems the last 2 days, we want to put a label on the 2 sides. So what are the names of the 2 sides we have? Opposite and hypotenuse. So if we had opposite and hypotenuse, which trig function are we using? Sine. So I'm going to say sine of 42 degrees equals what? X over 8, opposite over hypotenuse. And how do I get the x alone? Multiply by 8. And whatever I do to the right side has to also be done to the left side. So my exact answer is 8 times sine of 42. And my approximate answer is 5. Okay, so maybe that's the passcode. 5.353. We'll try again in 15 minutes.
Oh, dang!
All right. Now it says to round to the nearest 10th of a foot. What is? Don't worry, Courtney's phone is next. What is the nearest 10th of a foot for this decimal?
0.
1 decimal place. 10th means 1 decimal place. So we're going to say 5.4. 5.4. All right, now, story problems get what type of answers? Story answers. So that means we have to write our answer in a full sentence. So I'm going to say the height of the connection point
is about
on the tree is about, that was good, 5.4. What are the units? Feet. 5.4 feet. There's our answer. The reason that we are writing sentences as our answers is that we are interpreting the number for the person reading our paper. So when the person reads the sentence, they know that it's very clear that that 5.4 is not a degree measure. That 5.4 is in feet, and it describes how far up on the tree you're connecting the wire. In Math 3, our sentences are pretty obvious. Like the question was, where does it connect to the tree? And our answer was, it connects to the tree right here. When you get into classes like calculus or AP stats, when you write the sentence to give your answer, it's usually a little bit harder to write the sentence because you have to really think about what your answer meant. So that's why I'm making you do it now. I want you to get in the habit of anytime I have a story, I interpret my answer for the person looking at my paper. All right? So the job is for you to do. Because sometimes I have students who put the wrong, they'll be like, oh, 5.4 degrees. And I'm like, what? That doesn't make sense. So I just want you guys to think about what you're doing when you do it. Okay? All right, next example. Go ahead and flip your page over. We have a fire tower. We have a forest ranger that sees his partner on the ground at an angle of depression of 40 degrees. So remember what I said about angle of depression? What did I say?
Straight and then down.
Straight out and down. So the angle of depression is right here. Straight out and down. That's that 40 degrees. And that means that the triangle that we're actually solving is not this triangle down here that they drew and labeled. The triangle that we're solving is actually this one right here. You guys see that? Yeah, so that's what makes the angle of depression something that students often get wrong, because they don't realize that we're not solving this triangle down here, we're solving this one up here. Okay?
Is it always going to tell us that it's an angle of depression, or do we need to learn more vocabulary?
The other ones, angle of depression and angle of elevation, are like the vocabulary. Other problems might say it's the angle between the guy and the ground. And you'd be like, oh, that's that one. Oh, yeah. So the other ones, the descriptors, are not vocabulary terms. They're just like based on the picture. Yeah, good question. So if we have these two pieces of information, right? We know that the tower is 45 feet. We know that they are X distance, or the partner, the forest ranger's partner is over here, and we want to know what that distance is between him and the tower. So we just have to take those numbers, or that variable, and we have to label the sides of the triangle that we are solving. So what should we label this side as? X. And what should we label this side as? 45. And what are the names of our sides?
Adjacent and opposite.
Yeah, so this is adjacent and opposite. And if we're using adjacent and opposite, which trig function is that? Tan. So we've got tan 40 equals 45 over x.
Wait, where did 40 come from? Oh, the degree. Oh, where did 45?
40 was the degree, 45 was the height of the tower.
Okay.
So how do I solve this when that x is in a spot that's difficult to get to? Yeah, I'm going to cross multiply. You're not wrong. That's one way to do it. Okay, so if we cross multiply, what do we get?
X.
45 equals...
X equals 45. And then 40 equals 10.
Right, so x tan 40. How do we get x alone? Divide by tan 40. So our exact answer is 45 over tan 40. And then our approximate answer...
Oh, I'm guessing it's 53.6.
53.6?
54.
Well, it says it wants you to round to the nearest tenth of a foot.
So 54.
So it's 53.6. So a tenth, all of these have said a tenth. A tenth is one decimal place. All right? So 53.6, what are the units? Feet. Okay, so we're going to say feet. So how far is the partner from the base of the tower?
The partner is 53.6 feet from the base of the tower.
The partner is above. Quit just trying to play me.
It's also from the base.
That's why she loves
Oh, the base. The
She just my little girlfriend. That's why. I need me a little baby to listen.
okay.
Don't come in here, Becky. I'm talking.
You guys are so sassy today.
I need me a little baby to listen.
All right. The next one. It says, find the shadow cast by a 10-foot lamppost when the angle of elevation of the sun is 58 degrees. So these types of problems actually mess with my brain. I don't like them because whenever they start referencing the sun, I always want it to be this angle right here. Why is it not that angle?
Why is it not that angle?
Yeah, tell me why it's not that angle. What vocabulary did they use? Angle of elevation. Does this angle do angle of elevation? No, it doesn't even go straight out, right? Angle of elevation and angle of depression both go straight out, and then they go up or down. This one doesn't go straight out. It goes like down and over. So this one has to be the angle of elevation because it goes straight out and up. And that's what angle of elevation means, straight out and up. Okay. So the picture was already drawn, it was already labeled, so we know that it's right. So what should we write for the sides that they gave us? Opposite and adjacent. So what trig ratio are we using? Tangent. So tan 58 equals yeah, why is it 10 over x and not x over 10?
Because opposite.
Yeah, opposite goes over adjacent, so opposite should be on top. You guys missed that. All right, how do I solve for x? Cross multiply. So 10 equals x tan 58. And how do I solve for x? So we have our exact answer. Does anyone have the approximate answer yet?
16.
Okay, 6.2.
Oh, I can't.
And what should we write for our
The
sentence?
shadow cast is 6.2.
About.
Okay, so I'm going to say the length of the shadow Does anyone know why I keep using the word about? Why don't I just say it's 6.2 feet?
So you rounded it.
Yeah, I rounded. I'm using an approximate answer, not an exact answer. Good. Yep. I'm using approximate. In case you guys were wondering, oh, we're not ready to try the phone again.
Why you gonna be this for an hour? You gonna be sick. Yo, what if he get his phone back and then he messed up his password and he get locked up like like you know.
Wait, that's pretty messed up. We're laughing at the guys.
We're laughing at it, but you know it could happen.
You're laughing because you're glad it's not you. All right.
Can we see?
No, we still got more time. We still got more time.
Courtney's while we wait on his.
No, we're not.
Wait, how long have we been doing these problems? This still say 15 minutes.
Right.
Oh, it doesn't count down. It just says 15 minutes until
It
it's
used to
done.
count down.
It used to count down. I used to enjoy that as a teacher. All right, the next problem. The next problem. A ladder leans against a brick wall. The foot of the ladder is 6 feet. The foot of the ladder is 6 feet away from the wall. The ladder reaches a height that's 15 feet on the wall, and they want to know this angle that it makes right here. So what are the names of the sides that they gave us?
Oh, you got
Opposite.
That's
Oh, wait.
That's
Ooh,
wrong.
wrong. Adjacent.
Can't you just do Pythagoras?
It's 10.
We're not finding the third side. We're finding an angle. Yeah, they want to find that angle.
How do, like, if we're not given the picture, how do we figure out?
So what I would say for these is that when you draw the picture, if they reference a ladder, draw a ladder. If they reference a tower, draw a tower. If they reference a tree, draw a tree. And the reason I would say that is because it helps you to use your common sense as you do the problem. Because you actually, like, it doesn't just look like a triangle, it actually looks like it's supposed to look. And so what I do is when I read the problem, I don't think of the problem as a whole. I just draw it one piece at a time. So if they say something about a brick wall, I draw the brick wall first. And then with this one, when you have a ladder against a brick wall, there's really only two ways to draw it. You can draw it on the left side or the right side, and it wouldn't matter either way. You'd still get the same answer. So if you draw it one piece at a time, as long as the problem is worded well, you should be okay. Yeah. And typically, if I find problems that I think are not worded well, I will tell you guys not to do them. Yeah. All right, so what do we have? 10. X or theta, you can use theta if you want, equals 6 divided by 15. You can do 2 over 5. And then what do we do to solve for x?
Inverse.
Tan inverse, good. Tan inverse, tan inverse. So x equals, if we're going exact, we're going to say it's tan inverse of 6 over 15. If we're going approximate, what do we get? 21.8. And then when we write our sentence, what should we say?
the angle the ladder will make with the wall is about 21.
So the angle the ladder makes with the wall.
I get angle and angle. That's how I know I got doubt on myself.
And make oh man. Make sure you either put a degree bubble or put the word degree. That was good. I liked that. Alright, so it says we have a damsel in distress, and she is being held captive in a tower, so go ahead and draw a tower. I don't know how to draw a tower. I'm just going to draw a rectangle and call it a tower.
I drew a square and then stilts.
Here we go.
Tower.
And then it says, her knight in shining armor. What are you doing? Put your calculator down. Oh, your phone case? Clever. Her knight in shining armor is on the ground with a ladder. All right? So go ahead and draw a ladder.
Where does it go up to? The very top or like the middle?
It doesn't sound like it matters. Yeah, so just draw a ladder. It doesn't sound like it needs to go to the top. It doesn't sound like it needs to go any... Yeah. We can assume it goes to the top. I think that's an okay assumption. Does it matter if your ladder's on the right side or the left side? No. Nope. Right. So I'm going to go ahead and draw. There's my ladder. I think that the princess is all the way at the top. And there is the knight in shining armor.
She's not real close.
Rapunzel.
Rapunzel.
When the knight stands 15 feet from the base of the tower, so what should we label?
15 feet.
Where in the triangle is that?
The bottom.
That's the bottom. So here's my triangle.
Oh, I didn't even see this.
There's my 90-degree angle. And the 15 feet from the base of the tower is right there. He looks up at his precious damsel, and the angle of elevation to her window is 60 degrees. Which one is the angle of elevation?
Near the ladder on the bottom.
Okay, so near the ladder on the bottom. So 60 degrees, and we know that because angle of elevation is straight out and up. How long does the ladder have to be? So what side are we solving for?
The ladder.
The ladder, which is the hypotenuse. Yep, so I'm going to put x right there. Right. And which trig function are we using?
You put the 15 on the bottom.
I put the 15 on the bottom because it says that's how far away from the tower he is. We've got, what's this one called?
Or adjacent.
Adjacent, and then what's the other one called? Hypotenuse. So which one are we using? Cosine. So cosine of 60 equals 15 over x. And how do we solve that? Yeah, put it over 1. And we cross multiply. So 15 equals x cos 60. And then how do we solve for x? And this is an exact answer? Oh, this is an exact answer, yeah. Okay, so what do we think the code is?
It makes it exact because there are no
Okay. So do we think like 30-30?
Do all fives.
Do all even numbers.
Just tell her before she starts.
Dang.
All right, 15. Doesn't it? I thought it goes to an hour after that.
No, I thought it went to 30 and then an hour.
I don't know. It's been. I'll have to look. What did you say?
Give me an iPhone.
I'll have to look it up. All right, 30. So we're gonna say the ladder has to be. What are the units for this problem? Feet. 30 feet long.
How come you didn't put about? You crying about that?
Yeah, why?
Exact answer. You didn't have to round it.
Yeah. So this time the answer really was just 30. Just plain 30. No decimals. All right. Number 2. Number 2. You are 200 yards from a river. Go ahead and draw a river. I just drew like a squiggly line to show water.
That's a long river.
That's a long river. You are 200 yards from that river. So go ahead and draw a little person away from the river.
Where are we?
Doesn't matter. Yeah, somewhere away from the river. Because they're not in the river, right? They're away from the river, so just draw your stick figure away from the river. All right, and then what does it say about you?
We in a boat.
How far away from the river are we? 200 yards. Now, when you measure how far you are from a river, are you going to be like, okay, here I am. I'm going to measure how far I am to the river over here. No. You're going to go straight ahead, right? You're going to say as close as you are. So I'm going to measure from me straight to the river. That's 200 yards. 200 yards.
Can you pass it here? 'Cause I don't want to be out.
All right, now what does it say next? Do you walk along that path and take the 200 yards to the river?
No.
No, what does it say instead?
You walk to the river's edge.
Yeah, you walk to the river's edge, right? So we're not going straight there. Or we are going straight there, right? But we're not going like directly ahead. So it says that you're walking straight. That means you're not walking like close to the river and then away from the river and then following the river and then going to the river, right? It says that you walk straight to the river's edge. So what does that mean? Straight across. We're going to go straight to the river's edge.
Why would we go
Like straight across instead of going up.
So it says, do you see how this is kind of like walking along the river? Because you didn't go straight to it. You're not going perpendicular to it. You kind of walk along the edge a little bit and you're getting closer to it as you walk. Okay? And again, like I said, we're walking straight. We're not walking towards it and then walking away from it and then walking towards it again. So what is this length right here? 400. So 400 yards. Can we see that our right angle is right here? Okay. What do they say next in the problem? Find an acute angle. Is the right angle an acute angle? No. What's an acute angle?
less than 90?
Less than 90. Okay, so we have, it says find an acute angle, so it's talking about one of the other two. Find the acute angle between the path and the river's edge.
So that would be where you're sitting.
So that would be this one, right? Okay. What variable do you guys want to use?
D.
D. All right. So what are the names of these two sides? So which trig function? It's a, so Deja chose D. I have no idea why.
Deja.
All right.
She is recording.
So yeah, let's keep it appropriate. So so we chose that letter. Which trig function are we using? Sine. So we got sine of Deja equals equals opposite over hypotenuse, right? And how do we solve for Deja?
You gotta inverse.
Inverse.
I don't know if you can solve the Deja. That's a hard equation.
So Deja's angle equals.
Hey Deja, the little stick thing on that little stick. Oh, stick thing. That was a good one.
Did anyone find the angle? 30.
Oh, I spelled my own name wrong.
That is a shame.
So what are the units on that 30? We know our answer is 30 degrees. The angle between the path and the river's edge is 30 degrees. All right.